Hello again, this is the Pencrest High School AP Physics C video series. This is video 1F, three-dimensional vector notation. So, you are reasonably familiar with two-dimensional vector notation or planar motion vector notation. Typically we look at that as if it's an XY plane. We're going to now take our vector notations and extend it into 3 dimensions. If you can imagine three-dimensional space as X, Y, and Z axes, usually the vectors are indicated in what's called IJK notation. We'll get into what IJ and K refer to. They are unit vectors in the X, Y, and Z directions. Typically the XY plane is considered to lie in the plane of the page or the screen, and the Z direction goes out of and into the page. Typically the positive Z direction is towards you or out of the page, and the negative Z direction is into the page, although X, Y, and Z directions can be indicated in any conceivable direction, as you'll see. But to expand our standard sign conventions, positive direction is indicated by to the right, up, and towards you. The negative direction is left, down, and away from you. Now, getting a little more detail for IJ and K. IJ and K refer to unit vectors in the X, Y, and Z direction respectively. I is the X direction, J is the positive Y direction, and K is the positive Z direction. The little indicator over each of the is considered a hat, and it does indicate a unit vector. I hat, J hat, K hat. Typically you will not need to use the hat depending on if I wrote the problem in WebAssign or if it's a Halliday-Resnick problem. If I wrote the problem, you can just use the normal keyboard letters. If Halliday-Resnick wrote the problem, you'll probably have to use the IJ and K indicators in PhysPad. So we'll get into that. Each of these unit vectors has a magnitude of 1 unit regardless of what quantity is being indicated, what vector quantity is being indicated. It could be a force, could be a displacement, could be a position or a velocity or an acceleration. If you see I, J, and K, the magnitude is 1 regardless of the vector quantity. So you might have a typical position vector, x equals 3i plus 4j minus 6k. Assuming the units were in meters and assuming standard sign conventions, this would indicate 3 meters to the right, 4 meters up, and 6 meters into the page because the k hat has a negative 6 as its coefficient. Now, in a general sense, let's say we have a vector A. We'll call it a sub x I hat plus a sub y j hat plus a sub z k hat. The coefficients a sub x, a sub y, and a sub z represent the components of the vector. So again, we're familiar with our standard two-dimensional vector notation where we had a magnitude and a mathematical direction. We typically use the sine and cosine functions to calculate the x and y components of the vector. In three-dimensional vector notation, the notation itself gives you the components of the vector. So we don't have to do any mathematics to figure out what the components are because the notation, the IJK notation, tells us what those components are. So visually, if you can imagine sort of a cube, a rectangular prism, we have my x, y, and z axes using standard sign conventions. A sub x is along the x direction. You can imagine going this way. And then a sub y is positive and goes up. A sub z is out of the screen towards you. So when we look at those three magnitudes, right, up, and out, brings us to this point. The blue indicates my vector A. Okay? So that's actually, if we, by some chance, if we need the magnitude of this vector, it's found very simply with the three-dimensional Pythagorean theorem. The magnitude of vector A, simply square root of ax squared plus ay squared plus az squared. We could conceivably use other methods to indicate the direction of a vector in 3 dimensions, but we would need a magnitude and 2 angle measurements. In spherical coordinates, we're not going to go that far. We will, however, need the magnitude of the vector for purposes of multiplying vectors, which is what we will see in the next section. So that's 3-dimensional vector notation. It's also called IJK notation. We will see some vector operations, including addition and subtraction, which are easy, and then multiplication, which is not quite as easy. So until then, enjoy, and I will see you again soon.